A security reporting loop once handed me a beautiful CVE brief. Clean summary, confident severity, tidy remediation. The same agent had drafted it and then marked it ready. The problem was one missing constraint from the source advisory. That changed the impact. Nobody caught it because the reviewer remembered what it meant to write, not what the artifact had actually said. The loop did not fail loudly. It shipped a polished wrong answer. That is the expensive version of AI agent verification, trusting the maker to grade its own homework. Naive agent loops usually ask for output, then say, check your work. That feels reasonable until you watch it under load. The maker carries intent in its context window. It remembers the plan, the sources it meant to use, and the edge cases it thought about earlier. Then it looks at the final artifact through that memory. Missing facts get mentally filled in. Vague language feels acceptable because the intent was precise upstream. Worse, the agent often starts rewriting instead of judging. Now verification becomes another generation pass, with the same blind spots and a little more confidence layered on top. The pattern is simple and opinionated. Separate the maker from the checker. The maker creates the work. The checker evaluates the resulting artifact against explicit criteria. Not vibes, not whether it seems helpful. Criteria. The checker does not rewrite the artifact. It does not improve the prose. It does not rescue the maker. It returns a repair packet. Which criterion failed? What evidence proves the failure? And the exact fix required. This keeps judgment and generation from blending together. In production, that separation is less about using different models and more about using different roles, prompts, memory, and inputs. Mechanically, run it like this. First, define the acceptance criteria before generation starts. Second, have the maker produce an artifact, a brief, patch, test plan, summary, whatever your loop emits. Third, call the checker with the artifact and the criteria only. Avoid sending the full maker transcript unless a criterion truly needs it. Fourth, the checker returns JSON with status, failures, and past checks. Each failure contains criterion, evidence, and required _fix. Fifth, send only the failures back to the maker. That matters. If you send the whole transcript back, you rehydrate the old assumptions you were trying to escape. Take a CVE brief pipeline. The maker reads an advisory and writes a short customer-facing brief. Affected product, severity, exploit status, mitigation, and source link. The checker gets the final brief plus criteria like every severity claim must match the advisory. Exploit status must be explicitly stated or marked unknown. Mitigation must be actionable. Source link must be present. The checker finds criterion, exploit status stated correctly. Evidence. The brief says active exploitation observed, but the advisory only says exploitation has not been confirmed. Required fix. Change exploit status to not confirmed, and remove urgent exploitation language. That packet goes back. This pattern is not magic. If the criteria are mushy, the checker will be mushy. If you ask, is this good? You get theater. Ask testable things. Is there a source link? Does every claim map to the provided source? Does the JSON parse? Do all required fields exist? Checkers can also hallucinate failures, especially when they are asked to infer too much. That is why evidence is mandatory. A failure without evidence is just an opinion. And no, this is not a formal proof system. It is an engineering control that catches a large class of routine agent loop failures. Maker checker sits near the center of loop engineering. It connects to stop conditions because a pass result is a clean stopping signal. It connects to budgets because repair packets prevent endless full regenerations. It connects to state management because the maker and checker should not share the same crowded context by default. It also prepares you for later patterns: tool verification, test harnesses, evaluator routing, and escalation to humans. At the foundations tier, the main lesson is this: do not make one context window responsible for creating, remembering, judging, and repairing everything. Here is the 10-minute version. Pick one automation you already run: a meeting summary, pull request description, research note, customer reply, or ticket triage. Write 5 acceptance criteria in plain language. Make at least 3 objectively checkable. Then add a checker step that receives only the artifact and those criteria. Force the checker to return status, failures, and past _checks. In each failure, require criterion, evidence, and required _fix. Finally, change the retry prompt so the maker receives only the failures array. Run it on 3 old examples. You will probably find one quiet miss. Recap in 3 beats. 1. Makers are biased toward their own output because they remember the intent, the plan, and the conversation. 2. Checkers should judge the result against explicit criteria, not rewrite the work. 3. Repair packets keep the loop small. Failed criterion, evidence, exact fix, and only failures sent back. That is the foundation of practical AI agent verification. Tomorrow we keep building the reliability stack with another loop pattern you can use immediately. New loop engineering episode daily on this channel. Foundations first, then orchestration, guardrails, and fleet scale operations.